when you double click the maples, first of all, you will have this layout. Either your new document or new worksheets. So if document, let me show you the new worksheet first. Will be like this. In this mode, if the new worksheets will be worksheet mode, document mode will be like this. Where you can type in text. I want to type command, maybe easier. And for Maple, you can use any variable. You want to assign any value to any variable. For example, you want to assign a equal to 10. Then so if you call Maple is case sensitive actually. When you call a, it not recognized. So you call a, the value is 10. So the output is immediately. The document mode, easy for you to type in the documentation. For example, I want this one as a group. This is as a group, and you can type in the title. Let's say this is basics, for example. Then you can hide it. You can add in, let's say, other section, for example, like this. Let's say this one using evalf. Then I can close it, and then I can open it. For example, like this. And then here, so I open the previously type file. This one, if I open, this is already in the document modes. And then it's always easy. You type in restart to clear out all the memory. Then assign any value to variable name a. Name a. Let's say a colon 10. Call back using a. Maple is case sensitive. If you call lowercase a, it won't recognize b. If you type b equal, let's say 2, then when you call b, there's no value. So make sure the assignments, you must have colon equal. To clear value of a, value of a using here. Then you have what? So a colon equal like this. So a equal to a. So now, you can try to call back, see whether a contain the value 10. No more. So to clear the value of a, either you use a colon equal single quote a, or you can use an unassigned command to clear the value of a. Then let's say, because since a no value, so assign any value to b. Let's say b equal to 12. Call back b. B really is 12. Now you use unassigned. For any function in Maple, you have an open, close bracket. Now, if you use unassigned, open, close bracket, and then column b, something like this. So if you call back b, there's no value. So you have two ways to restart. Will clear out all the value for all the variable. So if let's say you want to clear value of a colon equal single quote a, or you use the unassign command, unassign, and then open, close the bracket, so single quote B. So you got two ways to clear the value of the variable in mapper. Okay, now perform symbolic calculation. Let's say G colon equal A minus B, okay, plus C. For multiplication, make sure you press shift 8 and then variable E, and this is not exponent, E power, you press shift 6. So power F, and then you want divide, so you can select these two, then backslash D, then you enter. Now assign the value of A equal to 5, okay. If you want to assign the value in the same line, make sure you separate it by semicolon. B colon equal 10, C colon equal 2, okay, and then now D is 5, E 9, F 4. This colon equal A is 5, B is 10 here. Must be semicolon. Okay, and then initially if you assign G is A minus B plus C times E power F divided by D. So we give you also symbolic, and then after that, when you assign all the value of all value for A, B, C, E, F, D, then now if you call G, it will calculate all the value of A, B, C, D, E, F will be substituted into G. Okay, and then mapper tends to give in natural display, or the natural display like this. So if you want to give the numeric or the floating point solution, you may use evalf. Okay, you can call percent. Percent stand for the latest output, refer to 13,097 divided by 5. Okay, or you can use evalf. This is the callback the G. Also can. Okay, if you want to give 2 decimal place to the previous output, then you may 2 decimal place to the previous output. At comma 6, for example. Comma 6, so mean total, you see 6 digit there. To delete each block, for example, I want to delete here, control delete. You can enter. Enter here. So if you want to insert text, insert the command. This button to execute the entire worksheet. This is selected groups. For example, I insert, then I want to delete, control delete. So the ways that I here, G colon equal A minus B plus C multiply E power F divided by D. E here, this is not, if you want exponent, make sure you click from the template expression. E power exponent A. This is a symbol. This E is actually just a normal variable named by E. So this way is actually called as a expressions, okay, assignment. This is not function. Okay, if you want function, okay, here, if you want to define function, okay, of x, okay, this function for one variable, this one function of two variable. This one you want to evaluate function of x, okay, when x equal to a. So if you already what's this? This one I can call the function fa, okay, function of a and b. Okay, so if you define the expression, and then if you want to substitute value of a, b, c, either you put out the value of like this way, or you can use the substitute commands like here. Substitute x equal to a into the expressions. Okay, example, you want to substitute x equal to 1 minus 1 into x squared plus xy plus y squared. So you use substitute, SUBS. Substitute x equal to y minus 1 into x power strip 6, x squared plus x times y plus y squared. So x will be substituted by y minus 1. So this is x. So substitute is used to substitute certain expression or value in an equation. Okay, so define f like this. So f colon equal 3 times x power 2. Okay, and then multiply y squared minus 2 times y plus 5 times x power 2 multiply y power 2. Okay, I define f, later on I substitute SUBS, substitutes, okay, x equal 1, y equal 2 into f, like this. Okay, or you want to use this template, then I call this f. Okay, since you already defined the f, and then substitute x is 1, sorry, y, x is 1, y is 2, y is 2. Okay, here. Okay, so substitute also equivalents to eval. Okay, so eval, okay, this is stand for evolution. The expression, eval the expression for x equal a, x equal a. So evaluate x squared plus x times y plus y squared if x equal to y minus 1. So you use eval for x squared plus x times y plus y squared. Okay, when x equal y minus 1. So you want to delete here. Evaluate x squared minus 3 when x equal 2. So eval, eval x, okay, powers, okay, minus 3. So x equal 2, like this. Oh, sorry. eval. Okay, next is eval f. I think just previously we have shown eval f if you want to give the answer in floating point. Evaluate using floating point arithmetic matrix. Okay, click pi. Okay, pi from the Greek template pi. They give you pi. So if you want to change pi to 3.14 something, evalf percent this one I think is followed by the O mapper templates. The O map version mapper, you need semicolon. Okay, use the last output and add with exponent x. So the last output we use percent, okay, exponent x, okay. Click the exponent, okay, template. Evalf, okay, square root 981. So click square root template 981. So if you want in percentage, floating point, evalf this thing. Or straight away you evalf square root 981. Okay, evaluate 10 divided by 3. Okay, so you may use evalf, okay, the percent, okay, or straight away evalf okay, or if you tap, okay, let's say 10 dot divide 3, or 10 divide 3 dot. If you know, if you want the answer in floating point, then one of the number, if you, okay, 10 dot mean you want in the floating point, okay, the output will prompt, okay, will automatically prompt mean display in the floating point. So if like this, so mean you want in natural display, then if you want to change the floating point, then you use evalf. Okay, control number of decimal place, 5 decimal place. So how to see, the last output you want 5 decimal place. So total 6. Because okay, 5 plus it, so total 6. Okay, the rest here square root 9, so 3. This one it give you cube, okay, cube root of 8, it give you this form. So if you simplify, you give 2. This is absolute, you click from this template here, absolute A, you got 3. Magnitude, also click from this template. Okay, capital I is a imaginary number. So this is calculate the magnitude of the complex number 1 minus I. Okay, ln, okay, from the ln template, here, ln A, ln 1, okay, ln exponent 1, okay, sin 3 pi over 2, okay, add sin. Okay, capital I is an imaginary number, I squared negative 1. To do the, okay, series from this template, okay, and then solve command, okay, for the solve command, okay, is solve the equation, okay, single equation or system of equation. Okay, first of all, you would like to solve the current I from V equal to IR. Let's say I define EQ V equal I multiply R. Then I solve EQ for I. Okay, and if you want to solve, okay, single equation, for example, okay, we'll factor out. Okay, this is quadratic equation. You can factor. Okay, and then I can after I factor, if I want plot. Okay, this is a plot. Okay. Okay, then put put x any interval that you I just put like this. So I get one of the roots here, x is 1. Another roots -5, so I put -6 here. And actually Maple you can type down and you can go up. Let's say I go back. I can solve percent. Percent is the latest output. Just now I go down, so this is the output. That's why I need to go up here and then solve percent. This is plot. Solution 2. Let's say I put this to the solution. Like this. And then I want solution number 1. I give him this solution number 1. If you want solution number 2, like this. I want to delete this. So factor this thing. 1 divide. Left minus 1. Left plus 1 divide x power is shift 6. And then plus 3 times x plus 2. So factor this thing. Then I solve percent. I will solve to find the root. So of course you get denominator cannot be equal to 0. That's why it's only 2x plus 1 equal to 0. You get x is -half. And then if I want to plot this thing, I can Control C, put it here. So this is a graph of this equation. So you notice then this graph, and then factor, this one already have. You can just the same thing. Example 4 for polynomial of degree 4, and then plot it, solve it. You get the same roots. Got 4 same root. This one, find the root of y equal 3x squared plus 4x plus 2. This is a imaginary, you got complex root. When you plot, it will display for the real root, which is -2/3. We can solve system of equation. For example, you want to solve 2 simultaneous equations, 3x minus 4y equal to 6 and 4x minus 7y equal to 8. This one, if I do, I delete. Can restart to clear out all the memory. Solve. I just call SOLVE, solve. 3 times x minus 4 times y equals 6, 4 times x minus 7 times y equal 8. Equal 8. And then you close the curly bracket, close the round bracket here. So it gives you x is 2, y is 0. So you want to plot, copy this thing. So your plot must be function of x, unless I use implicit plot. If you want to directly plot this one must be function of x, or else I call with plots. With plots. You got one of it implicit plot. Then this one I change to implicit plot. And then I want to plot 2 graphs simultaneously. Then like this. Implicit plot, you got x and y, so you must put out the interval for x and y. Let's say x equal just simply put negative 5 dot dot 5, I say y, negative 5 dot dot 5. So if the range is not nice, then you just change from here. So if you x and y, okay, define implicitly, you just use implicit plot. If you want to plot, then okay, like just now, plot. So here you see plot must be function of x only. So in this case, if you want to use plot, you must express y as a title. In this case will be okay, this one. If you want to use plot, if I want to use plot, I must plot, express y as a title, will be 3x minus 3 times x minus 4 divided by minus 6, this one, divide by 4. So mean if you want to use plot, make sure okay it's a function of x. So express y as a title. So you got 3x minus 6 divided by 4 for the first equation. Second equation separate by comma. So express y as a title. So you got 4 times x minus 8 and then divided by 7. Okay, so negative 5 dot 5. If plot, okay, I just need a interval for x. So if you want to label the y-axis, you may comma y, something like this. Okay, so but if you use implicit plot, you can define x and y in the equation, and then you must provide interval of x and interval of y. So this one solve these three simultaneous linear equation. So same thing, curly bracket, x plus y plus 2 times z equal 1, comma 2 times y minus z equal 1. Then you comma 3 times x plus y plus 2 times z equal 2. If your x is half, y is half, z is 0. Okay, this one we plot, this one we will call. Okay, if you don't want to show out all the command in all the built-in function with plots, you just colon, then yeah. Okay, to solve non-linear equation, so you solve if you put x minus cos x. Okay. So x minus cos x. So if you use solve, if we give you like this, so means because this is actually non-linear equation. So to solve the non-linear equation, normally we use the fsolve. We give you one of the roots. Okay. And you plot the graph of this non-linear equation. Okay, and then now solve the non-linear system. We restart with plots. Okay, define the f, x squared plus y squared minus 8 times x minus 4 times y plus 11. Okay, g is x power 2 plus y power 2 minus 20 times x plus 75. Okay, 75. Okay, later on I implicit plot. Okay, I want to plot, since I define f and g already, okay, f, g. Okay, you see what's the difference? Is scaling constraint or not constraint? Like this. They're not in their actual ratio. Okay, this is using command, or you can right click. You can see here. the style, the line, okay, color, and anything, okay, formatting for the graph. You can just right click if you don't know what command to put it there. So then we solve a F and G. So if you use solve, okay, again, because this is non-linear system, if you use solve, it give you like this. Then the correct one, you use the fsolve. FG. So it give you only, okay, the first root, the first root here, where x between 4 and 6. Okay, if you want to get this root, so you can specify the value because fsolve is actually normally, okay, give one of the root. If you want to get another root from the graph, we know, okay, the roots between, let's say, x 6 to 7, let's say y 2 to 4, then we specify the range. Okay, then you get here, you get the second roots. Okay, after that, expand to expand the expression. So expand x plus 3 times x plus 2. Okay, expand x plus y power 3. Why not expand? Oh, I must bracket. For any function, okay, you must put out the bracket. So the same thing for here. Then the rest you can have a try. Okay, the data I want to show is the combine. Okay, combine. So if you use combine like this, combine percent. So here, so we expand sin 4x, you get like here. When you combine back, you get sin 4x. Okay, because like, let's say like this, and then if I use, let's say, simplify this one, and I one more time enter this one, simplify. Okay, sometimes simplify, it won't simplify back, that's why I combine. Like this. You see, so for example, you can combine two integral, combine the limit, combine the exponential term. Sometimes simplify can do, okay, same with combine, but sometimes cannot. So this one you combine. Okay, so this particular solution, let's say, is here. If I simplify, you see, it won't simplify. Okay, but if I use combine, okay, here the cos squared, okay, cos squared t plus, mean the term sin t cos t becomes sin 2t. So it's like, if you do manually, it's like you substitute cos squared t equal to 1 plus cos 2t divided by 2, and then sin t cos t is the half of sin 2t. You get the same solution as what combine. So means sometimes you simplify certain expression, it won't simplify, then you use combine. Okay, later on, coefficients is extract a coefficient of a polynomial. Okay, coefficient, okay, of the p, okay, x, or you want, mean n is an order. Mean, okay, I will normally use coefficients. Okay, for example, if you expand, I restart, you expand x plus y cubed, okay, and save it into variable eq equation. Okay, extract coefficient of the same power of x. Let's say order 0. You need this one normally in ODE when you solve undeterminate coefficients, okay, or solve the differential equation using power series, okay, you want to extract the same power of x, okay, same power of term, then you use coefficient, okay, function to help to do that. Let's say here coeff, coefficient, the coefficient for equation, I want x, okay, same power x, let's say x power 0, x power 0, y cube, okay, and then I just copy, I paste. So this is x power 1, y squared. And then order 2, x squared, coefficient of x squared is 3y, but 3. Coefficient for x cubed, 1. Okay, if you want, let's say I copy everything here, then from here I insert, okay, and then I paste it. Okay, now I want to extract coefficient for same power of y, same power of y. So here I change to y, 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 y. Right on that. So coefficient for, okay, y power 0, y power 0 here, x cubed. So y power 1 is 3x squared, 3x squared. Y power 2, 3x. And then y cubed, coefficient is 1. So this is the purpose of coefficient. Okay, collect is actually collect coefficient of like powers. Okay, normally, for example, EQ here, you got 2p plus 4 times 2px plus q minus 2 times px squared plus qx plus r minus 2x squared plus 3x minus 6. Okay, if I collect EQ for x squared, it's actually, it do something like sorting. It's sort. Start from x squared, x power 1, this is a x power 0. Okay, and then if you got this one, so it collects, okay, from, sorry, I haven't collect DEF, okay, mean collect the, okay, for the derivative, collect for the derivative. So it will collect, okay, start from second derivative, first derivative. Okay, and then later on we have the simplify. So SIMPLIFY, simplify. Okay, let's say 4 power 1 divide 2, okay, plus 3. So this is a square root 4, 2 plus 3 is 5. So I can delete. Okay, simplify sin x squared plus cos x squared. So it's simplify sin, and then power shift 6, okay, x, make sure bracket, plus cos power shift 6, okay, any function must be open, close the bracket like this. I can delete. Okay, this one I just copy, put it here. Okay, and then convert is convert an expression to a different form. Normally is I use it for convert partial fraction. Let's say f is 3 times x plus 1. Okay, I want to select everything, divide by x squared minus x minus 6. Enter. So I want to get the partial fraction, I use convert f to PARFRAC, partial fraction. So same thing for second example here. You can directly, let's say, convert x squared minus 15 times x plus 41, and then highlight it, backslash x plus 2 multiply x minus 3 power 2. Okay, then I can click comma PARFRAC, partial fraction. So you get the 3 partial fraction. Okay, later on series to generalize series expansion. For example, find power series of exponent x, it's just series. Okay, exponent, click the exponent template. Okay, like this. If you want more expression, let's say you want until, let's say or let's say I put here comma 10, 9, or the x power 10. So same thing, you can copy, chain. I want to, okay, for example, let's say 2x. I mean x replaced by 2x. Okay, so same thing with others. Sin x comma x. Series, let's say cos x over x. Okay, you want hyperbolic sin cos series. Sorry, sin, hyperbolic sin. Okay, if you want, let's say series, okay, exponent negative x. So series is used to get the power series expansions.